Welcome to nCast, the podcast from add-ons. Each week, we'll explore the world of cloud cost management, the latest in AWS optimization, and getting practical about your FinOps journey. Join us as we dive deep into the latest trends, tools, and best practices, while having conversations with leaders and luminaries who are innovating on the front lines. Our goal is to provide value to the community through insights and practical advice that will help you to achieve your FinOps goals. So whether you're in engineering, leadership, finance, or a cloud professional, this is the place for you. Sit back, relax, and get ready to join the conversation on nCast. Hello, everybody, and welcome to this episode of nCast. This is a very exciting episode for us here today. We've teased it a little bit that this is going to be our All Things Karpenter episode. And to join us for that conversation, this is also very exciting to me. I've got Jeong and Andrew Park, who are partner solutions architects from the Service Acceleration for Container Services team. That's a mouthful over at AWS. Guys, do you want to introduce yourselves?
Yeah, for sure. I'll kick things off. Thank you for having us. My name is Andrew Park. I'm one of the senior partner solutions architects here at AWS. And a lot of my focus is on exactly what you talked about, containers. So really working with all things EKS, ECS, and really all the services that kind of support that ecosystem. But making sure that our partners and customers are kind of following the best practices when doing so. So again, thanks for having us on. Really excited to be here.
Cool. Welcome.
Hello, everyone. I want to say good morning, good afternoon, good evening, where you're at, wherever you're listening to the podcast from. And thanks, James, for hosting us. My name is Jeong. I am also a partner SA here at AWS on the Service Acceleration team. I think our team is technically called the app modernization because we cover containers and serverless. Mm-hmm. So as a partner SA, my roles are pretty similar to what Andrew does, helping our partners integrate or create solutions or improve their product with our containers and serverless services. I cover both. So that's why I had to throw the serverless in there for a little bit, but essentially be that key trusted advisor between our partners and our service team so that we can kind of coexist in a symbiotic way, provide services and solution and the ultimate goal is to benefit our customers so that whether it's us, whether it's AWS, whether it's the partners that's driving that success, we're all aligned in that goal. We help our partners drive that to success. So I know I spoke a lot, but essentially I do the same thing as Andrew as well.
Awesome. Well, thanks again for joining us today, guys. Today we're talking about Karpenter. I've been building on AWS in my capacity, leading engineering teams for leading engineering teams for longer than I'd like to say. I'm older than I look, and building on AWS for over a decade now. I was lucky enough to start building services in cloud native world, and so I watched container orchestration come on the scene and launched our first service on AWS that was in the Mesos Marathon ecosystem. And then, when there was still the container orchestration wars going on, I started to hear about Karpenter, in the last 2 years, and we started to look at it very seriously as a team, probably about a year and a half ago, when we were thinking about our advanced scheduling technologies, vertical scaling, horizontal scaling, and some of the new technologies that have come onto the scene. Can you just, for everybody out there, start us out with a basic, what is Karpenter?
Yeah, I can kind of kick that off. So before I get into that, I think it might be helpful to kind of think about this particular phrase I'm about to give in the context of the conversation we're about to have. Because I think one misconception that I see a lot with customers is that they don't treat the application as the first class citizen. It's usually backwards, where they try to have the infrastructure be the first class citizen and the application try to fit into whatever the infrastructure needs. But when you think about containers and really just any of our workers, not even EKS, but ECS as well, you have to think about it in that context where your workload is the main priority and everything else surrounding that workload needs to be able to support those particular requirements. And this is a misconception that I see a lot of customers. And I think when we talk about this in the context of Karpenter, this will start making a lot more sense. So for the folks listening to this podcast, just keep that in mind that as we continue this discussion, that the application needs to be the first class citizen and not the other way around. And when you think about it in that context, Karpenter itself will actually make a lot more sense. But yeah, so basically Karpenter is basically the open source product that was released by our services team to address being able to scale clusters based on workload requirements on EKS specifically. And when you think about something like Cluster Autoscaler is more of a general kind of open source tool for all kind of distributions for Kubernetes, where Karpenter is definitely much more focused on EKS, right? So the idea that with Karpenter is Karpenter basically manages the instances directly without having to use things like node groups and auto-scaling groups. And really the main key here is that it brings scaling management closer to the Kubernetes API. Whereas when you think about something like Cluster Autoscaler, it really heavily is dependent on things like auto-scaling groups and having to deal with things like managed node groups in order to appropriately scale, right? And so when you think about the phrase that I just kind of gave out, it's much more focused on understanding what the workload is and then scaling appropriately based off that. And I think as we continue this discussion, I just want people to kind of keep that in mind.
Yeah, it seems like we kind of have to go through a mental shift. I mean, we went from the data center era, and then we all became comfortable with auto-scaling groups. And so when node groups came on the scene, it felt like a comfortable model for us. But then, you know, with container orchestration, at any given time, our workloads or the workload requirements that, you know, the pods, the containers, everything that needs to be scheduled may have a unique set of dimensions. And so what you're telling me is that the Karpenter is really decoupling that infrastructure layer and being so focused on what instance type that fits, you know, a very rigid node type selection. And it really frees you from having to think about a lot of things, doesn't it?
Yeah, for sure. Because even with things like Cluster Autoscaler, like if you take a look at the source code, it doesn't really understand like the true concept of like an AZ, for example, right? And so that's why, for that reason, it's kind of a manual process in that you kind of have to set up those autoscaling groups and manage node groups ahead of time so that Cluster Autoscaler can then talk to those things and then scale appropriately, right? Whereas with Karpenter, that's not necessarily the case. Because Karpenter actually understands things like the different instance types. It understands all constraints, really the things that you would need to appropriately be able to scale your workloads on EKS. And so I think that's kind of an important call that a lot of people don't really think about is Karpenter is it's just a better product, in my opinion, because there's less things you have to worry about, right? And also when you think about it in the context of even just being able to define the specific instance types that you want Karpenter to provision based on your scaling requirements, like that's huge, right? And so, yeah, definitely a big fan of Karpenter.
Right. And so I think Karpenter comes with a lot of presets. Even, I mean, to get started with Karpenter, it seems like you don't really have to think about a lot of those things. It's best just to see how Karpenter behaves to become a believer, right?
Yeah, I mean, if you think about it this way too, it's kind of like relationships in a way. Like Karpenter just really wants to understand your needs and your requirements, and then kind of scale based off that. So, I mean, if you really think about it that way, like that's really what it's doing. It's like, for example, like if I have a workload that needs to run on ARM, right? Karpenter will do everything in its power to understand that specific request, and then bring up an instance that's ARM based for that particular workload. Whereas with Cluster Autoscaler, a lot of that ends up becoming a manual process. And so I think that's why it's so important for folks that are looking at Karpenter, really just Kubernetes in general, to kind of shift that mindset, right? Like it's application first. And that's exactly what Karpenter does. I want to understand everything about the actual workload itself and then scale based off that, right?
It also feels like Karpenter takes advantage of a lot of built-in goodness in AWS. I think about the way that it interacts with Fleet, and a lot of spot scoring that Amazon provides out of the box. Is that one of its true superpowers? Is the native integration with different AWS services?
Yeah, I'll let Yen take that one.
Yeah, so essentially think of it as, how do I put this the right way? A step that you skip when you compare it to cluster autoscaler. So we've talked about, with an autoscaler, there's this intermediate step of node groups, which then, acts as a scaling mechanism for your cluster using the scaling group and configurations and things like that. Whereas once you deploy Karpenter, you're able to, and based on the configuration that you set, you're able to talk straight to the EC2 fleet. So there is a bit of a latency / performance gains to be had when you're using Karpenter versus Cluster Autoscaler. And we can kind of dive into different parts of what makes Karpenter stands out versus Cluster Autoscaler.
Well, before we get there, why don't we talk about some of, from your perspective, the primary problems that face EKS users today, or the EKS users face today? What are some of the top categories that they might look to a solution like Karpenter to address?
Yeah, I can kick that one off. I think the first one that initially comes to mind, especially today's market, is cost management, right? Like, Kubernetes in itself can be very expensive, especially depending on the workloads that you're trying to run, right? So I think cost management, cost allocation ends up being a really big pain point for a lot of customers, right? Just because when you think about EKS and the ecosystem that surrounds that, there's a lot of things to think about. And more often than not, those things that surround the EKS ecosystem cost money, right? And so really just trying to understand like where people can save on cost when they're running EKS ends up being a big one. And then the other one is, I guess like infrastructure automation or management, in that, it's not hard to spin up a cluster. It's everything else that comes after that, right? So like what mechanisms can we leverage today to kind of bootstrap that process, where I can kind of build out a blueprint and say, hey, like every cluster I deploy needs to come with things like Cert Manager. Let's say Stellium for my CNI. Maybe I want to use something like Karpenter, right? Like ideally, especially in the era of like platform teams, the better we can kind of automate this process for platform teams and the like, the better it'll be for customers, because that ends up being a pretty big pain point. It's like, hey, like I'm spending all this time trying to get all this operational software up and running in the cluster, so that how can we automate that and make that a better experience for customers, right? So I think those would be the two things I call out there.
Okay. All right. And, we have a pretty good sample size of AWS spend to kind of analyze. And obviously, the biggest portion of EC2 spend, we see it happening in our customer base. And the percentage of what I call EC2 unmanaged is quickly being eclipsed by what I call EC2 managed. And, the dominant extent of EKS, we think, oh, it's going to just be built on an EKS build, but it's all EC2, right?
Yeah, I mean, you hit it right on the nail. I mean, EKS is backed by EC2. Naturally, most of the spending comes from EC2. And it kind of goes back to the earlier point that Andrew mentioned, and it's kind of all intertwined in a way, is, how do you make autoscaling or just kind of instance spend more efficient and more performant, and therefore, make it more cost effective? I think one of the things that we could think about is ensure instance being well utilized. That is indirectly affecting your spend. For example, are your nodes being underutilized because you have some limitations as to how you configure your auto-scaling mechanisms? I think this is one of the points, one of the powers, I would say, of Karpenter is, I think we call it Karpenter, I don't remember the exact phrase, but it's like in right-sizing node scaling or something to that effect. It's this idea that we want to make sure we're provisioning the right type of instances for your workloads. Again, going back to workload should be your first-class citizen. Kind of this idea of being able to right-size the instance that fits your workload. Therefore, you're not provisioning as many instances. You're utilizing your instance to the full effect. therefore reducing costs. So there's a lot of things that are kind of working together to make this whole wheel spin in the way that you want.
Yeah. Interesting aside. So we recently over at NOps built a dynamic auto-scaling feature, automation feature around auto-scaling groups. And we were doing resource utilization analysis around auto-scaling groups. And we started to find these auto-scaling groups that had, the desired capacity, 40, 50, 60 nodes, desired capacity or in the auto scaling group, and we were seeing percentages of those nodes that were giving leading indicators of actually being idle up to 40-50%. And when we went and did a closer analysis, what we found is that many of those auto scaling groups were actually EKS node groups that were under cluster autoscaler management. And we started scratching our heads saying, that's not how Kubernetes is supposed to work, right?
100%, right.
Right. But it was just like, we were just looking at the data going, what the heck is going on with these autoscaler groups? And we thought, oh, we could just tune oh, wait a second. These are not regular autoscaling groups, right? I always like to say a node group is just a sort of autoscaling group, masquerading as an EKS node group underneath the hood. They can look like the same thing.
Sure.
So, that definitely was a forcing function on my side to say we have to start looking at solutions like Karpenter to think about doing this differently. If we see such a high percentage of our customers who are under a huge amount of pressure to cut costs, and they've got these fleets of nodes that are just sitting there doing nothing, right? So definitely led us down this road to Karpenter for sure.
Yeah, and this kind of goes back to the whole notion of being able to puzzle it correctly would be the phrase I would use. From a cluster autoscaler or autoscaling perspective, you're kind of limited on, choosing the right instance size, and maybe your workload doesn't quite puzzle it in correctly. So then you have to, provision another node or provision another instance. Whereas depending on how you configure your Karpenter, you could, you can select the right amount of instances or instance families, or you can leave it blank and let the Karpenter do its magic of determining workloads, what the request might be, and then just sort of let it play some Tetris, find the right instance that can fit all the workloads to minimize the number of instances that you have. Like you said, I've done some of my own research, and I would highly encourage those listeners out there that are thinking about Karpenter or using Karpenter to do their own performance testing. At the end of the day, we're talking about workloads. Workloads are different depending on, who the customer is or who you are, or what you use it for. And make sure that you're, it's a two-way street. You can do some things to optimize things on the Karpenter side. You obviously have to do some homework on your end to determine the right size for the workloads. But when you do that, we've seen that, things like you see from your end, 50%, 60% utilization, all of a sudden goes up to, 80%, 90%, some even at 92, 93, 95%. So that's sort of the performance gain or the efficiency gain that you see from Karpenter.
Right. Yeah. Go ahead.
Oh, sorry. Yeah. I think Jeong brought up a good point when, we're talking about make sure that you're using this appropriately for your particular requirements and your particular needs, right? So I think it might be helpful to kind of give almost like an overview of where sometimes Karpenter may not be the best fit, right? I think it's kind of important to lay that ground so that the folks listening to the podcast kind of understand like what they should be thinking about while they're doing this testing, right?
They heard it here, folks. Just the juicy stuff, as they say.
Yeah.
Right.
So when we think about Karpenter, right? Like Karpenter is basically removing a layer of AWS abstraction, and then it helps to kind of bring almost like this level of flexibility that's directly built into Kubernetes, right? So the way I like to think about it is I think Karpenter is best used for clusters with workloads that might have like high periods of spiky demand or have like really diverse like compute requirements. And when you think about it, like when you think about like managed node groups, like auto scaling groups, Those are really good for clusters running workloads that tend to be a bit more static and consistent, right? Like if you have workloads where you can kind of like almost predict the usage, or if you don't anticipate there's gonna be a ton of spikes with respect to the particular workloads themselves, like you could argue that Cluster Autoscaler might actually be a better fit for that particular requirement, right? And if with that said, with Karpenter, you have so many different ways that you can kind of customize the way Karpenter runs in your cluster. And even if you look at even just like the many annotations that you can provide for your deployment files, like it can be a lot, right? So really, like, just want to emphasize, like, for the folks that are listening, like, really understand your workload requirements, do the proper load testing, do the proper benchmarking, and from there, like, you'll have a pretty good idea of like which one you should use and which one's be better for your use case, right? And so, yeah, just wanted to call that out just to make sure that people understand at least that part.
For sure, for sure. Well, I mean, I'll implore people to keep staying tuned for upcoming announcements, because we're going to start talking about our nCast. We're calling it nCast, folks. Yeah, we'll announce it here first. Launch, which we like to think about as Karpenter and NOps working better together. And one of the things that we've learned, and again, we process over $1 billion of AWS customer spend through the platform and help them to optimize all of that. And that one of the things that we've realized in this endeavor is that these tools are often pretty cluster centric. So I would assert that there are possibly use cases where you wouldn't think about migrating to Karpenter. But if you start to think about workloads that happen outside of your EKS, even if your EKS is pretty static, there is an opportunity for Karpenter to compensate for things that have changed outside of your environment. Say you've got savings plans that aren't being burned down. Say that you've got RIs that are underutilized. Karpenter is so flexible that you can retune the provisioner and start to compensate for things that happen not even just at an account level, at an organization level. So, I hope to hear that increasingly there's going to be more and more use cases where you weren't thinking about Karpenter, but your environment it's so dynamic in so many ways that the customers that do have those more static workloads can start to shift things in and build some balance in their environment. With that, I see three, big headlines. If I go to the Karpenter open source website, three big headlines: improved availability, lower compute costs, minimize operational overhead. And I may be leading you down an interesting road here, but tell me about how Karpenter improves availability, because I think that might open up some interesting discussions.
Yeah, I mean, we could go in a number of directions. First is, with the granularity in which you could configure your Karpenter provisioner, or the way your Karpenter is set up. You can start to consider things like, multi-AZ by the requirements that you set. There's ways to use case native features like node selector, affinity. I mean, these are pretty standard case operations. But you can do things like AZ, instance type group, and it doesn't just lend itself to availability of the zones necessarily. There's also things like, if you're using spot instances, Karpenter allows for quicker retries, just in case that, when you first try to secure a spot instance and you're not able to, it can do a much quicker retries. We've actually seen that a lot to be the case for some of our customers. So availability could mean a lot of things in that sense. And obviously you'd set things like RI and savings plan that you could kind of incorporate as part of your Karpenter. And this is where it gets from single provisioner to multiple provisioner. And, that obviously adds some complexity to it. But I think that the idea here is, once you get the hang of how a provisioner works and what sort of choices are available to you, I think it's really easy to not replicate, but create different provisioner that fits some type of workloads within your cluster or your system, that lends itself to more availability or more types of availability that you can have based on your requirements. So a little bit of upwards in complexity, but I think the payoff or the gain is much more significant for the time that you have to put in to get everything working.
Well, I'm
So I don't
definitely
know if I answered your question.
Oh, you
Right?
did. You fell right into my trap. I was hoping that you were going to bring Spot up, right? I hope that was going to be part of the conversation. So one thing that we know, again, and going in, analyzing customers who are trying to use Spot and seeing how successful that they're being with Spot, especially if we don't see any Karpenter in their environment, right? First thing I do, if they're on EKS, I go and look for tags, right? And I'll say, all right, we've got K8 tags. Sometimes I see spotted tags. Sometimes I see Karpenter tags in there, and then sometimes I see this blend of I have K8s and I have Spot. But I don't see anything that leads me to believe that there's any sort of what I consider to be like effective Spot management going on, which my head goes straight to Cluster Autoscaler. They are using EKS, Cluster Autoscaler, and sort of bootstrapping that or cobbling together features to leverage Spot with Cluster Autoscaler. The other thing that I can tell you is that if you go and do analysis, and this, no offense, I mean, I encourage people to try all of these options, but most of them aren't doing Spot very effectively with Cluster Autoscaler, or they're frustrated beyond all get out trying to do Spot with Cluster Autoscaler. So, leading into the next discussion, a lot of organizations out there are trying to figure out how to do Spot effectively. There's a spectrum of solutions on EKS and Spot, but a lot of them are starting to land on Karpenter. Why is that?
I'll let you start off, and then I'll
Yeah, so I think we kind of go back to this idea of two things. One, we kind of already talked about, so I guess we technically talked about both. It's just the flexibility and efficiency. So the fact that you're able to directly talk to EC2 Fleet is a very powerful tool that a lot of people don't realize. It's where, and it kind of ties into number two of flexibility. So I think I briefly mentioned, obviously with Provisioner, you're able to set, Spot versus on-demand or both, or C6 family, or I'm just throwing numbers out there, but M5, C6, you have these different ways of restricting what you're looking for in terms of different configuration requirements within a provisioner. Or you can let Karpenter do its magic. You just leave everything blank. Obviously, you got to set up a Spot, and Karpenter is built to be able to utilize and in an optimized way of selecting Spot that you don't actually get from other ways of orchestrating your autoscaling capabilities. Now, the inner workings of the engineering of that, I'm not privy to, but that's how we have seen it. That's how we see it from the team. That's how we have tested. And we encourage, like I said, we encourage everybody to kind of test things out. Make sure it fits your requirement, but that's just sort of like the key point of how Karpenter is able to fully utilize its power to optimize Spot selection.
Sure. And if I'm just here, go ahead. No, you might have been going this same direction, but no, it's first.
Yeah, I think one other call out that I think makes Karpenter a much better candidate for Spot utilization is the idea that it can handle Spot interruptions natively. Whereas with Cluster Autoscaler, it is not possible. Like, you have to do that at basically the autoscaling layer or the managed node group layer, right? And so I think that the fact that it's a native feature within Karpenter makes Spot a much more feasible option for customers running EKS. And so that's the only thing I wanted to come out to that.
Sure. No, I think that native support, again, we're getting to a fully integrated framework that takes advantage of like all the native support, the fleet integration, the spot termination handler. And then, because of fleet, if you don't know what fleet does, I mean, the Spot is very good at asking for the cheapest possible, or excuse me, Karpenter's very good at asking for the cheapest possible thing. It's not available. It's going to go down the list because it knows the exact dimensions. It just really broadens your ability to play the spot market, right? Because it's going to have this broad swath of instance types that might be suitable for the exact workload that's trying to be scheduled at any given point. Now, I think that incorporating tooling that probably takes other parts of the spot market into account, that's going to be another thing that we see. But Karpenter is also very open, so there's a lot of incentive for the community to continue building and sort of extending capability on and around Karpenter.
Yeah, I mean, just the fact that it's a community-driven project, mind you, AWS created it.
Sure.
We're always getting, collecting feedback, and as the product, the product is getting to its maturity level. Can't tell you where it is. I mean, it's still kind of early in its inception, and we're still taking feedback. There's a lot of community action, and with that, there's a lot of community asks. And obviously, it does a great job of spot interruptions or spot handling. There's still some edge cases that we see, and the team is always taking feedback to figure out how to engineer so that we're able to make it more efficient going forward. And this isn't just for Spot. There's different things. One of the biggest things that the customers are asking is different types of church detection. So, isolated nodes, what happens, can we automate AMI upgrades for source nodes from certain provisioner? What happens when you change provisioners? Can it, go downstream and kind of regenerate or reprovision some of the existing nodes? So that's one of the things that we see. I'm sure there's other feedback or feature requests that the community has put. So it's really a community-driven effort, or at least we would like the community to kind of get involved. And it's great to see someone like NOps implement it into their offering or their product. We love when we see this in action from others.
Well, and that's what's so exciting for us. We've got a tremendous relationship with AWS, right? That's number one. We feel like we have so much support from both the AWS internally, the Karpenter community is totally open, and we're excited about investing in a lot of these things that folks are talking about, right? We're excited about sort of organizational level, turning on that NOps engine that is already optimizing and tuning commitments for our customers, and then integrating all of that data and those decisions into provisioners so that we can help our customers to make the most optimal decisions for their workloads, right? Spot termination detection, right? Really innovating and advancing spot termination detection, because I think what we hear out in the field is that the number one objection to moving to a solution like Karpenter plus Spot is fear of spot termination. I think a lot of that fear is unfounded. EC2 computers can disappear at any time. No offense, they're highly available, but they are computers, right? Like computers fail, and that's sort of like why we moved to solutions like EKS to begin with. The other thing that we're talking about and where we're going to contribute a lot of IP is in the area of workload reconsideration. Right. I made a decision at any given point, and I heard you sort of hinting at that at that moment that decision was the most effective. But spot markets change, demand goes up. My own resource utilization across other EKS clusters or even other accounts in my same organization will change. And so we're excited to contribute there. We're going to be talking week after week after week about this stuff. But I kind of want to dial us in to one of the biggest questions, because we're, again, from the field, we're talking to customers every day. And the common theme that we get from our very EKS-centric customers is that they are talking about Karpenter, right? Like almost every engagement we go into, it's like, we talked about it last week. We talked about it the week before. And they all have their own unique set of problems that they're trying to solve. But everybody is looking to this generation of technology because they know there are advances, optimizations, reliability improvements, you name it. There's just a lot of advantages to it. But then the question that comes up and the fear that comes up in every case is, hey, my EKS workloads are pretty stable. They scale pretty well. My engineering time, my product management is asking me to build new features daily. They're not asking me to think about frameworks like Karpenter. So there's a big conception that migrating to Karpenter is going to cause them to have to devote a lot of engineering resources to, this migration. And so I want you to talk us through, how easy is it to take my existing EKS workload and migrate it to Karpenter?
I mean, it's just like any other deployment. Remember, Karpenter is simply a deployment, or installing, I guess, for lack of a better word, into your EKS cluster. It's just like any other resource you would. Now, there are some configurations to be done, IAM rules, tag subnet, or security group. You got to update your config map. These are normal things that you would do, whether it's Cluster Autoscaler, load balancer, controller, or Karpenter in this case. And the only difference is obviously, if you're migrating from Cluster Autoscaler to Karpenter, you just want to do all the setups and, decommission or depermission all the nodes through Cluster Autoscaler. But I mean, there's not any extra steps here that you would need to consider in order to move a workload from Cluster Autoscaler managed node group to a Karpenter managed node group. And I think another thing I would like to add, and I think Andrew mentioned this probably towards the beginning of our show here, is, and this goes with all sorts of things that you want to do with EKS cluster, is automation is key. And these are things that could be automatable. I don't know if that's a word. Easily automated. Let's put it that way.
There you go.
So just think of it.
I like it as a word. I like it as a word.
Yeah. Okay. Let's call it automated.
You heard it here first.
Just like, this is automatable, just like everything else you do when you're thinking about EKS provisioning. Obviously, there might be some, extra steps into your automation that makes this a bit complex, but I don't think enough to have to think about, committing resources or committing time, taken away from, true core business value development that a lot of the customers might be worried about.
Yeah. Well, we're definitely going through that journey with a lot of NOps customers right now. And, again, I think the common theme is like fear and time. And so the reward really has to be worth it for engineering teams to sort of look at an existing workload. But we all understand how the tech industry is today. I think that the theme for 2023, every AWS event that I go to is how do I help my customers to save money? I've heard it all the way across the board because budgets are tight. We know where the industry is at. So the conversation becomes increasingly less driven by, how many nines did I deliver, and increasingly more driven about how do I operationalize around cost optimization, which is why I think Karpenter is like one of the coolest tools out there to talk about. Well, we've been at it for a while here. We've covered some major ground. Guys, what parting words would you have for the community out there that's listening and thinking about taking the plunge or taking a closer look at Karpenter?
Yeah, I'll kind of kick that one off. So it's kind of like what I said at the start of this call, this podcast is, remember, your workload, your application is number one. Everything else that you do after that should be supporting that particular workload. And I think that's something Karpenter does really well, because at the end of the day, if you think about what Karpenter is doing, all it's trying to do is understand the workload's requirements. And based off that, it will then act appropriately based on what that workload actually needs. So as you're doing your load testing, as you're doing your before start marketing, just keep that in mind. Like, you have to be able to do these things first in order to make like real effective use of something like Karpenter. Because if you don't do these things ahead of time and you don't really understand the requirements that your workload actually needs, then it's going to be a not so fun process trying to configure Karpenter. Because if you don't know your workload requirements, then you won't really know how to set up Karpenter, right? Because with Karpenter, there's so many different annotations that you can add based on your particular requirements, that if you don't know those requirements in the first place, then Karpenter ends up being kind of hard to use, right? The other thing I would want to call out is that automation is key once again. So the more frameworks and approaches that we as a community can kind of come together to build, the better experience it will be for anyone really just trying to use Kubernetes or EKS, right? Like Jeong mentioned, like Karpenter is very much so an open source product, and very much so a community-driven project as well. So if there are particular features that are not available at Karpenter today, we highly encourage you to submit those issues on the Karpenter GitHub page, because those things are reviewed very, very regularly. And the product team is very committed to making sure that they are trying to address all of our customers' needs. And the last thing I would say is Jeong and I actually are one of the maintainers for the EKS Blueprints project for the AWS CDK. And in that, we have created basically reference architectures, if you will, like codified reference architectures that will allow you to basically use Karpenter and all of its features using the AWS CDK. So we would highly recommend all the folks listening to the podcast check that out as well. Because like I just said, the better ways we can automate these types of things, the better experience will be for people trying to use EKS and things like Karpenter. So I think those would be the three things that I would want to kind of end with.
Yeah, I guess I'll add a couple things here. Obviously, Andrew just mentioned workload is key, identifying what you have, and, how you should be utilizing Karpenter is a huge key in making it a success. Having said that, it does open the door for the art of the possible. I mean, let me just name off a few things. You may have a mixture of workloads that has different architecture, ARM versus AMD. You may have workloads like machine learning, data intensive workload that might require GPU. You have things like quick versus long running workloads. These are all kinds of different types of workloads that can be utilizing different provisioner within your Karpenter to kind of separate things out. Therefore, you're controlling efficiency and performance gains across the board of all your workloads. Now, you may just have one type of workload. That's also fine. But we've seen that from an enterprise or, bigger customer use case, we see different types of workloads that lends itself very well to using Karpenter to kind of utilize all the capabilities that it has. And one of the interesting use cases that we see is, like I just mentioned, we're seeing an increased adoption of data-centric workloads, staple workloads around analytics, processing, AI, ML. We have a project called Data on EKS. Highly encourage you to check it out. A lot of its components are around things like EMR and EKS, or different types of open source tools that customers are using on EKS. But what we're seeing is all of these are trying to, or we have reference architectures to use Karpenter for our faster scheduling, or different kind of provisioners for things like drivers versus executors. If we're talking about big data workloads, it even works with some custom scheduling tools like Unicorn or Volcano, if you've heard of those tools. Mm-hmm. So there's a lot of exciting things that are happening, and Karpenter's kind of at the forefront of those projects. Now, it does come with trial and error. Some we do support, some we don't support, some we've seen that the community has been able to successfully implement it. So like going back to Andrew's point, this is a community-driven project. So we highly encourage you to kind of push your boundaries and see what you can get out of Karpenter. And the last point I'll make, I don't want to make this too long for all the listeners out there, is if you are afraid or if you're scared, I think that's one of the things we talked about. Start small, kind of see, small part of your workloads, make a decision and see how Karpenter works. I know we talked a lot about Karpenter over Cluster Autoscaler, but as we said, there might be workloads that are suited for Cluster Autoscaler, to be honest. It's not a session to like push everybody into Karpenter or away from Cluster Autoscaler. Right. Again, going back to the whole notion of know your workloads, how it works on Karpenter, and make or determine the best choices that you can make. And I think this is where somebody like nOps could come in with their product to kind of help you make that decision easier.
Right. Yeah, that's really what we're here to do, is to help engineers take action, right? And to automate those things so that the engineers can really focus on innovation. My takeaway here is sort of the crawl, walk, run. That's what I'm hearing. Or think about the FinOps journey, which is like inform, optimize, operate. And it always comes back to that inform stage. A couple of weeks ago, we talked about using the vertical pod autoscaler to go through and just run it in the no update mode so that you can start to profile your requests and your limits so that you can get your pods right sized, in a quick fashion. It's always that informed step, like doing the work to know your workload. We hear all day about analytics workloads. My workload is stateful. It runs a long time. I'm scared about termination, all of those things. But it seems like Karpenter has a lot of support, and that's where the community piece comes in, because you are not the first one that has run into this issue. Your workload is not unique. We're all doing it. We're all hearing the same things. And so if we work together, we can leverage these technologies to really push the limits of what's possible in efficient and optimized computing. Well, guys, Andrew, Jeong, it's been great. Like, this was the coolest conversation. I can't wait to get this out there. Hopefully, you guys are welcome on anytime. We're going to be announcing nCast here in a couple of weeks. And so maybe there's like a whole other conversation to be had around the sort of landscape of optimization and how the things that you do outside EKS impact what decisions you make in EKS. Anyhow, that's it for Edcast today. If you're still listening, you're probably as nerdy as us. So thanks for sticking with us. We get really excited about this stuff, as you can tell. So hope you join us next time for another interesting conversation. Goodbye for today.
Thanks, everybody.
For sure.
Thanks for tuning in to nCast. We hope you enjoyed the episode. As you can tell, we love to geek out on all things cloud optimization. If you have any questions or feedback, we'd love to hear from you. You can find us on LinkedIn, Twitter, or Instagram, or just shoot us an email at ncast@nops.io. If you'd like to learn more about the continuing innovation over at nOps, or about our free FinOps platform where you never pay anything unless you save money, check us out over at www.nops.io.